Let's tune the telescope into galaxies being born. And oh my gosh, who ordered this? We're finding galaxies in the dark ages. For as long as scientific inquiry has delved into the origins of our universe, the prevailing explanation has been the Big Bang theory. Countless studies and the collaborative efforts of thousands of scientists have reinforced this theory, providing substantial evidence for how the universe came into being. However, the landscape of science today is markedly different from that of the past. Technological advancements continually usher in new theories and perspectives, challenging what we once considered indisputable truths. In this evolving scientific landscape where new discoveries reshaped our understanding of the cosmos, Neil deGrasse Tyson has become a prominent voice. Now, a groundbreaking development has come to light as the James Webb Space Telescope has unveiled a revelation that calls into question the long-standing Big Bang theory. This discovery involves the detection of a staggering 750 new galaxies, each of which defies our previous expectations of what galaxies should be like. And by the way, the James Webb Space Telescope was conceived and designed to help us understand the origin of galaxies, so we shouldn't be surprised that it's forcing us to scratch our head. Join us as we explore how the new images from the JWST debunk the Big Bang theory with the discovery of 750 new galaxies. Scientists have put forward the Big Bang theory as the leading explanation for the origins of our vast universe. According to this theory, around 14 billion years ago, the universe came into existence through some sort of mysterious cosmic event. It's the ultimate birth story of the cosmos. The surprising nature of the images captured by the James Webb Space Telescope has challenged scientists' understanding of the universe's origins. The hypothesis that these images directly contradict is the Big Bang hypothesis, which has long been regarded as an unquestionable truth by the majority of cosmological theorists. These galaxies appear to be too small, too smooth, too old, and too numerous when compared to the predictions of the Big Bang hypothesis. The small size of the observed galaxies entirely contradicts the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger with increasing distance. According to the Big Bang theory, at the very beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into an extremely tiny and highly concentrated point. This point is called a singularity. This is a point where infinite density exists. When we say infinite density, we mean that the matter and energy within this singularity were squeezed together to such an extent that their density reached an infinitely high value. The concept of a singularity comes from our current understanding of the laws of physics, particularly the equations of general relativity proposed by Albert Einstein. Within the singularity, all the matter and energy in the universe existed in an extraordinarily compressed form. The extreme density implies that an enormous amount of mass and energy was concentrated within an infinitesimally small space. While the space isn't much of a problem here, when there's so much pressure and density, you've got unimaginable heat. The temperature within the singularity would exceed any temperature that can be observed or reproduced in our current understanding of the universe. The energy stored within this hot, dense point was the seed from which the entire universe would unfold. That's why the singularity marked the beginning of the universe as we know it. It was the origin from which everything in our cosmos came from. After the initial singularity, the universe started the journey of expansion and inflation. This process occurred over the course of approximately 13.7 billion years, shaping the universe as we know it today. The expansion of the universe started with an extraordinary burst of rapid expansion known as cosmic inflation. During this phase, the universe expanded at an unimaginable rate, far exceeding the speed of light. It's like the fabric of space itself was stretching and stretching, taking everything within it along for the ride. Cosmic inflation played a massive role in shaping the large-scale structure of the universe. It smoothed out irregularities, homogenized the distribution of matter and energy, and set the stage for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed down. But with this information, it's important to note that even though the initial period of cosmic inflation ended, the universe continued to expand at a measurable rate. This ongoing expansion is known as the expansion of the universe or cosmic expansion. Scientists have observed the effects of this expansion through various observations such as the redshift of light from distant galaxies. The redshift indicates that as the universe expands, light waves get stretched and shifted towards longer wavelengths, shifting them towards the red end of the spectrum. We'll get into the details of this later on in the video. At first glance, the images of the new galaxies that were taken by the JWST telescope look absolutely breathtaking in a good way. You can see hundreds of galaxies all in the same frame, and the sheer power in the photos is something you just can't ignore. But that's what things look like to the average person. For researchers, things are the total opposite. These pictures are surprising to say the least. They don't match what scientists thought they would see based on their theories. In fact, they are seeing way more galaxies than expected, and these galaxies are different in some surprising ways. They are smooth, smaller than imagined, and really old. All these surprises are causing a bit of a panic among the scientists. One paper even starts with the word panic in its title, so you know things are serious. The galaxies look nothing like what they are supposed to. The age of the observed galaxies seems to be incredibly strange here. The JWST observations indicate the presence of galaxies that appear to be unexpectedly old. This challenges the expected timeline of galaxy formation and evolution within the framework of the Big Bang theory. Plus, there's also the fact that the abundance of observed galaxies is a lot higher than what it was supposed to be. The Big Bang hypothesis predicts a certain distribution and density of galaxies based on the expansion and evolution of the universe, but the JWST images show a massive number of galaxies, which raises questions about the accuracy of the predictions made by the hypothesis. There's also the fact that the smoothness of these galaxies is totally unexpected. The Big Bang theory suggests that galaxies should exhibit irregularities and variations in their structures due to the dynamics of their formation and evolution. However, the JWST images reveal galaxies that appear unusually smooth, lacking the expected level of complexity and roughness, which is what you'd normally expect to see in the images according to the Big Bang theory. While the expansion was happening, we basically had all the stuff that makes up our universe squeezed into an incredibly small volume. It was clear that matter could not survive in space like this, so something had to give. As the universe expanded and cooled down, transformations took place. Particles such as protons, neutrons, and electrons begin to interact with light and energy in their surroundings. These interactions played a pivotal role in shaping the formation of matter in the universe. During the first few minutes after the Big Bang, there was a process called nucleosynthesis. This process involved the creation of lightweight elements like hydrogen and helium. The extreme temperatures and conditions during this phase allowed for the fusion of protons and neutrons to form these simple atomic building blocks. Hydrogen, the simplest and most abundant element in the universe, was formed primarily during this early period. Helium, the second most abundant element, also emerged during this time. These elements were instrumental in setting the stage for the formation of stars, galaxies, and more complex elements that would come later in cosmic history. The synthesis of these elemental building blocks was a significant milestone in the evolution of the universe. From a primordial sea of particles and energy, the early universe transitioned into a state where matter actually began to take shape. This process was what laid the foundation for the rich diversity of matter and the vast cosmic structures that eventually came into being. Now, the Big Bang theorists themselves anticipated observing galaxies that were mangled and scrambled due to multiple collisions. However, the JWST images present a different story. Instead of chaotic and disheveled galaxies, the images reveal overwhelmingly smooth disks and well-organized spiral forms resembling the galaxies we see in the present-day universe. This unexpected observation challenges the notion that mergers are a common process in the evolution of galaxies, because it's clear that these new galaxies haven't gone through any of the hardships that you'd normally expect if you were following the Big Bang theory. If there are actually just a few or no mergers happening out there, it becomes implausible for tiny galaxies to grow and become hundreds of times larger. This implies that these galaxies were never originally tiny to begin with. Along with it, the optical illusion predicted by the expanding universe hypothesis, where objects appear smaller with increasing distance due to expansion, also doesn't exist. As astronomers have meticulously observed and mapped the cosmos, they have discovered a striking pattern: the clustering of galaxies and the overall structure of the universe. Galaxies tend to congregate together in vast groups, clusters, and superclusters, forming intricate networks that extend across the cosmos. This observed large-scale structure aligns with the predictions made by the Big Bang theory. According to the theory, the universe began as an incredibly dense and hot state, and over time, it expanded and cooled. As the universe expanded, gravity played a pivotal role in shaping the distribution of matter and the formation of galaxies. The gravitational effects predicted by the Big Bang theory are consistent with what we observe today. Gravity draws matter together, causing galaxies to cluster in certain regions and form in intricate filamentary structures that connect them. These structures reveal the cosmic web-like pattern of the universe. The presence of these galaxy clusters and the interconnected web of matter provides strong support for the Big Bang theory. The formation of galaxies and their distribution across the clustering of galaxies, the cosmic web-like structure, and the distribution of galaxy clusters all come together to support the idea that the universe has evolved from a primordial state of extreme density and has undergone expansion over billions of years. So when you take another look at the size of the galaxies the James Webb Telescope found, you can really see how the images portray a completely opposite reality to what we've always thought was our reality. According to Big Bang theorists, these tiny galaxies grow and evolve into the larger galaxies we observe today through a process of collisions and mergers. To make it easier to think about this hypothetical scenario, you can think about the individual galaxies as a magical toy car, one that starts as a centimeter-long vehicle but grows into a full-size SUV by colliding with numerous other toy cars, gaining size as it goes. But the thing is that the observations made by the James Webb Space Telescope have cast doubt on this proposed merger process. If we were to believe the toy Big Bang theory evidence car analogy, one would expect to see at least some evidence of collisions or dents, if you will, in the interacting galaxies. So is the Big Bang theory just some wordplay? Actually, it is supported by some compelling evidence. First of all, you've got things like the observations of the redshift of light from distant galaxies that provide evidence of the expanding universe. The observation that galaxies are moving away from one another in all directions suggests that the universe is continuously expanding as predicted by the theory. The abundance of light elements such as hydrogen and helium found throughout the cosmos is also consistent with the predictions of the Big Bang theory. But not just that, the large-scale distribution of galaxies, which is something that was revealed through astronomical surveys, matches the predicted patterns emerging from the Big Bang theory. One of the most significant pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background. The CMB is a faint radiation that fills the entire universe and represents the afterglow of the Big Bang. This cosmic radiation was first detected in 1965 and has since been studied extensively. The characteristics of the CMB align closely with the predictions made by the Big Bang theory, providing strong confirmation of its validity. The observed pattern of the CMB radiation, including its uniformity and temperature distribution, supports the idea that the universe was once in an extremely hot and dense state before undergoing expansion, which as we've discussed earlier on in the video was one of the main things that happened during the Big Bang. The presence of the CMB provides a remarkable glimpse into the early stages of the universe, serving as a direct echo of the initial moments following the Big Bang. Its discovery and subsequent analysis have played a crucial role in cementing the Big Bang theory as the perfect explanation for the origins of the cosmos. So everything we've been believing this entire time was nothing but a lie. Subscribe to the channel for more space news and discover the truth.